asked what you wanted me to cover in algebra, and inequalities came up quite a few times. Inequalities are, well, the symbol for inequalities are these symbols here. Yeah, they come up quite a bit, so we can do a quick video on that. That means is greater than, and therefore that must mean is less than. So in other words, 8 is greater than 7. I'm sure we can all agree on that. And 7 is less than 8. I'm sure we agree on that. How do we remember them? Well, there's a couple ways of remembering them. There's the way that it always points to the smallest number. That's one way of doing it. To the smaller number. Like it's an arrow, so this is pointing at 7, which is the lowest number, and here it is pointing like an arrow pointing at 7, smaller number. Another way, in mnemonics we've got, there's like a crocodile with his eyes there, and he always wants to eat the bigger number. Or we could do Pac-Man. That's terrible, Pac-Man, but Pac-Man always wants to eat more. Always wants the bigger number. Okay, fair enough. Let's move on. What is the equivalent, what is the difference between that and that? And sometimes I've even seen it written quite often, and it's, in fact, it is up here where there is the sort of the line at the bottom. This means strictly greater than. This means greater than or equal to. All right. So your age to get in a nightclub the age to get into a nightclub in New Zealand, as long as it's a proper permanent nightclub that doesn't cater to underages or anything like that, you've got to be greater than or equal to 18. If you're 18, you can get in. If you're 17, you're not supposed to get in. You will get in trouble, and the bar would get in trouble. That's what that means. All right. What does that one mean? So x, if I say x equals 17 and you came along and you said no, x does not equal 17, it's like we have an equal sign and we're kind of putting a stop sign on it, a sort of no excess past this point through it. X does not equal 17, or does not or cannot equal 17. That's what they mean. All right, so far so good. The good thing about using inequalities is that you can use them exactly the same as an equal sign. You can add positive numbers, subtract positive numbers, multiply, divide, do anything you want with an inequality. The one thing you cannot do, well, I guess you can do it, if you multiply or divide both sides by a negative number, you must flip the inequality sign. Okay, so let's say we have negative 3x plus 2 is greater than 4. And we wanted to solve it for x. Well, we'll go about it exactly the same thing. We would take 2 away from both sides, and that's fine because we're not multiplying or dividing by negative 2. We're just taking 2 away. They're going to cancel, and that's going to go to positive 2. So then we would have, if we bring this across a bit, we would have negative 3 is greater than positive 2. We want to get rid of this negative 3. So let's divide both sides by negative 3. They're going to cancel. X is greater than negative 2 over 3. Is that right? No, that would be wrong. We need to flip the inequality. That would need to go. It would need to flip from being is greater than to being is less than. Right, that needs to flip. Now let's do some questions just so we can anchor that into you. So this one here is 2x plus 5 is less than 13. Okay, we just treat it like an equal sign until we need to divide or multiply by a negative number across. Let's take 5 away. Take 5 away. So 2x must still be less than 7. 7? 5. Yes, 5. Oh no. 13. 8. 2x must be less than 8. We divide both sides by 2. Divide both sides by 2. They're going to cancel. We divided by a positive number, so we're fine. So x must be strictly less than, but not equal to 4, because 8 over 2 is 4. Let's do number 2. And this one is 7 minus 3x is greater than or equal to 1. Okay, first thing we want to do is we want to get rid of the 7. Take 7 away from both sides. We can do that. We're not multiplying or dividing by negative 7. We're just taking it away. So negative 3x must be greater than or equal to negative 6. And now we want to get rid of this negative 3. We divide by negative 3 there, and we divide by negative 3 there. They're going to cancel, and this is going to be equal to positive 2. The x stays there, but what needs to happen to the inequality sign? We divide by a negative. We divided by a negative sign, so this has to flip. And it has to flip properly. We can't lose that other less than or equal sign either. All right, let's move on. More questions. This is number 3 now. 4x minus 9 is greater than 3x plus 2, and we want to solve for x. Let's bring this 9 across, so let's add 9 to both sides. Give myself a bit more room. So 4x, and remember that stays where it is, must be greater than 3x plus 11 now. And let's bring this this 3x over. So I'm going to subtract 3x from both sides. Well, I'm subtracting the x. Do I need to do anything? No, we're fine because we're just subtracting. We're not multiplying or dividing. So 4x minus 3x is just 1x. So x must be greater than 11. And that one would be done. All right, next question. Minus 5x is less than or equal to 20. That works. So now we've got a little bit of a problem now because we want to divide both sides by -5. I don't know why it's put an arrow on there. Divide both sides by -5. Divide that side by -5. When we do that, this has to flip. So x is going to be equal to a number greater than or equal 20 divided by -5, which is -4. Remember, a positive side divided by a positive number divided by a negative number is a negative number. All right, we cleared the whiteboard a little bit. Now we can do this last question. So there isn't really much there that should be freaking you out. Let's do everything and just ignore that until we might need to use it. So let's expand out the left hand brackets. So 2 to the 3x minus 1, that's going to be equal to 6x minus 2, must be greater than 4x plus 5, and we want x on one side, so we can just take 4x over. We're not violating our primary rule because we're not multiplying or dividing by a negative number. We're just subtracting a negative number. So 6 minus 4 is 2x, must be greater than 5. And then we want to divide by 2. They're going to cancel. This is not going to flip sides because it's not a -2. So x must be 5 over 2, which is 2.5. That's that. All right. Now let's have a look at some quadratics. So this will tell us, essentially, this will tell us when is this graph above the x-axis, when it's below the x-axis. So all of this must be less than 0. We're going to treat it as 0 until we need to use it. So let's look at this. So x, we don't even need that. X squared minus 5x plus 6. Now two numbers there, minus 3 and minus 2. Yes. Just thinking out loud. Minus 3 times minus 2 is positive 6. Minus 3 minus 2 does equal minus 5. So our answer for that is going to be x minus 3. x minus 2 equals 0. Let's means that x must be equal to positive 3 and positive 2. Yes. So what an effect that tells us is that this graph is going to kind of look like that, and it's going to have positive from ever up to positive 2, and after positive 3. It's going to pause and then load it up so you can see what I'm. Yeah, did a quick little graph there, and what that tells us is that this is because it's less than 0, and the x-axis is when y equals 0, between 2 and 3, and there's positive 2, there's positive 3, so everywhere there is below the x-axis, so that's less than 0. Okay, we might need to do the same for the next one, I think. All right, same line of questioning. We'll do this one now. Sure, I have a pen going. So this one is x squared plus 3x minus 10 must be greater than 0. But greater than 0, remember this is all y equals. Y must be greater than 0, so it's all going to be sort of above the x-axis. That's everything that's above the x-axis essentially, and that's what this inequality means. So let's see if we can factorize it. It has, yeah, two factors, -5 and +2. So we could factorize it x minus 5, x plus 2 is greater than 0. So that gives us our 2 marks that are where it crosses the x-axis. There is a positive number here in front of the x squared. So low down dirty way of doing it is, if remember, if ax squared plus bx plus c, if a here is positive, it's going to look like that, which means it must cross it at +5 and -2. Okay, so when we come to graph this, it's going to be everything above there is what we want. So this is true if x is greater than 5 and x is less than 2, because this is the 2's where it actually matters. So all numbers greater than but not equal to -2, and all numbers greater than but not equal to 5 meet that criteria. So we would say -2. That would be true in this case. All right, this one here. Solve this inequality. How would we do that? Well, 2 is less than 11, so we don't need to worry about the 2 and 11 bits. So let's do them both separately. So 3x plus 5 greater than 2. That's doing this one here. X plus 2 plus 5. Let's take 5 away. Divide both sides by... Yeah, divide both sides by 3. Well, no. So that's -1. I'm just going to continue up here. So -3 over 3 is equal to -1. So x must be greater than -1. And for this side here, that must be equal or less than 11. So 3x plus 5 is less than equal to 11. We're going to subtract 5 from both sides. The 3x equals 7. Six even. Whoops. 6. Go away. Go away. Go away. 3x must be less than or equal to 6. Divide both sides by 3. So x must be less than or equal to 2. So x must be between -1 and equal to or less than 2. Do you want me to do that again? I'll do that. I'll do that again because that wasn't entirely clear. Hang on. Let's just rub this off. Wasn't entirely clear. Okay, so we're solving this one up here. 2 3x plus 5. And we're solving it for x. What are the values of x that will make this true? Well, 2 is less than 11, so we don't need to worry about those two interacting. So we'll do it ignoring the 11 for a start and just with this inequality. So 2 must be less than 3x plus 5 if we take 5 away from both sides. That gives us -3. And then if we divide both sides by 3, and we're allowed to do this because the thing we're dividing by is not a negative number, and that's going to go to -1, and they're going to cancel. So our first inequality, x must be strictly greater than -1. Okay, now let's do this part of the inequality. So 3x plus 5 is less than or equal to 11. Let's take 5 away from both sides. And that's still going to work. So 11 is going to be 6. So 3x must be less than or equal to 6, and we'd divide both sides by 3. Again, we're not dividing by a negative number, so there you go. X must be less than or equal to 2. So our final answer is that. In order for this to be true, x must be some number strictly greater than -1 and equal to or less than +2. Now we have a slightly tricky one. This is a slightly tricky one, and it's this one. The absolute value. Oh, that's a shocking line. That's almost as bad. The absolute value of x minus 4 is greater than 3. Now, what numbers would make that true? Well, the absolute value means the plus minus value when we ignore plus minus. If we had a 7 here, say x was equal to 7, 7 minus 4 equals 3. So that wouldn't be true, but any number greater than 7, so x greater than 7 would give us a true equation. So 7.1 minus 4 would be 3.1, which is indeed greater, less than 3. So therefore anything number less than 3, let's try that. A number less than 3, so 6. So 6 minus 2 is 2. 2 is indeed less than 3. Okay, so x has to be a number less than 7. Now, is there a negative number or any number on the other end which would make that equal? Well, 1 minus 4 is minus 3, and absolute value would be 3. So it's got to be a number which is greater than, x would have to be greater than 1. So if x was, yep, that works. So in other words, our answer for this one, x has to be in 2 places. X must be less than 7, and it must be greater than 1. I think I'm going to check. Hang on. Yeah, I think I'm right. So if we let x be -4, say -5, -4 is -9, that number is less than 3. Okay, so that bit's right. Let's let x be 10, some number much bigger than 7. So 10 minus 4 is 6. 6 is definitely not greater than, definitely not less than 3. So therefore that cannot be the case. So our number is x must be somewhere not equal to 1 and 7. Oh. Alright, for this one, let's do a little sketch. So we're told that the rectangle, imagine I can draw a rectangle, has sides of x and 12 minus x, and the area must be at least 20. Okay, so x, 12 minus x, must be at least greater than or equal to 20. I guess what we could do is we could expand out these brackets. So 12x, and then we're going to get a negative x squared. Ooh, okay. And that's going to be greater than 20. So guess we'll bring this 20 over. Yeah, we'll bring the 20 over and just solve using the calculator. I think I'm pretty at the end of my day, so zero. Gotta grab our calculator. Although if we multiply both through by negative 0, negative 1, okay, I'm going to play around with it. I'm going to multiply both sides by negative 1. And I'm going to get x squared minus 12x plus 20, and when we multiply both sides by a negative number, that has to flip, and now it becomes manageable. So numbers that multiply together is 20 are negative 2 and negative 10. So therefore 2 and 5, and I suspect that they may be the end limits. What is that going to look like? It's going to, the negative parabola, so because it's got the form negative x squared plus 12x, so it's going to look like that. So they must be the cutoff dates. So x must be greater than or equal to 2, and it must be less than or equal to 5. And there you go. The dog's starting to go nuts again, so I have to go check on it.